Nanti kecanduan loh saya turun. Baby sama mami. Ini. No, panas ya, panas. Yuk, di atasnya, satunya, biar atas. Kenapa rambutnya begini? Hot.
Okay, hello Mike. Hear me? Okay.
Yeah.
Okay, I can hear you also loud and clear. Well, how are you doing today?
Yeah, I'm fine.
Give me some update.
Some updates.
If there is any.
I don't think I have any. Yeah.
Yes, okay. Do you have any homework to ask for today?
Yeah. Can I leave and join back and use data?
Yes, please. Okay, Aryan, can you hear me loud and clear?
Yes.
All right. Any updates on that?
No.
Okay. Any homeworks to discuss today?
No.
Okay. You would notice that I've given you, I've sent you and Michael chemistry question practices, yeah?
Yeah.
So if there is no question from your side, now those are questions from my side. Okay. If you feel that you want to practice AMAT, that's fine. But today I do specifically choose chemistry. So if there's nothing urgent with AMAT, then please practice this chemistry question. Michael has some homework, so I will attend to his homework first, and then we can hopefully discuss together the chemistry questions. Okay.
When are we gonna discuss the questions?
Yeah, we are. So I want you to give it a try first. If they are too easy, then excellent, right? Good. But if they're too hard, I will periodically ask you time to time. So this is like your homework that you're asking me. I'm gonna follow your working, and I'm gonna help you with it, basically. Okay.
Yeah.
Now you can refer to the Jamboard in the mid-year talk, but I've sent you in WhatsApp. Okay. You notice that some questions are out of the mid-year topic, please tell me. Most probably it's not, but if you notice that, just tell me. Okay.
Yes, sorry, what do you say?
If the topics seems to be out of mid-year, right? Then yeah, most probably it's not. But if you notice that it is out, just tell me.
Yeah.
I only selected the most previous topic, the most current topic.
Yeah.
Michael, come. Let's ask your question so that later we can talk about chemistry.
Yeah.
Oh, Aryan, make it landscape, please.
Oh, yeah.
All right. Aryan, when we talk about the chemistry questions, we'll be using the mid-year talk Jamboard. Again, the mid-year talk. So in case we need to communicate. Michael will continue to use the previous Jamboard, so I'll add some dates to that, right? Because it's not full yet. Yeah. Right, Michael, I'm seeing your working. I'm seeing your question. I need to zoom in a bit. Looks like it's a physics question. For the Jamboard, I think you are at page 10. Okay, excellent. Okay. Okay, so okay, would you put the paper down a bit? Cannot see. Just like no, down, as in sorry, up, sorry, up first. It was cut off a bit. Okay, then go down. Then go down a bit. Sorry, it's a bit cut off. Okay, nice. No. Just a bit. Sorry, it makes it very hard to copy. Move up. Okay, thank you. Let's stop there. Stop. Okay, now move down, please. Okay, nice. Thank you very much. Now, what is your question, Michael?
It's at the back.
It's at the back. Okay, show me the back. Okay. Right. So is it part D? Is that what you're saying?
Part C and D.
C. Okay. So what about part C? You read them. Determine the potential. Okay. Right. Okay. So why do they tell you temperature?
No idea.
That's bad.
The temperature is heat energy.
Again, seriously, you don't know why they tell you temperature. For example, in part B, they do tell you temperature, right? And how do you use that temperature? Is that relevant? You wait. This is taking too long to answer. You do not know why a temperature is relevant in this question, really?
No.
How about part A then? You answer part A, right?
Yeah.
Wait, are you sure? But answering part A? Just a minute, Aryan. Answer part A. Your answer seems to be okay, yeah? Your answer seems to be okay. And you don't get why the temperature is relevant in this question, really?
Or to tell you what's it called? The resistance.
Okay, which you can get from the Where can you get the resistance? I guess your aim is correct. Oh, okay, I want the resistance. That's great. Where do you get it from? All right. And the resistance in temperature 100 is, have you ever read that before from the graph?
Yeah, it's 1.
Looks like 1. Yeah, looks like 1 resistance. Cool, cool. And how do you use it in B?
In B.
Yeah, do you use it in B?
Yeah.
And the resistance, your resistance in B, because I cannot read that. Is it 6?
Yeah. It is.
How do you get 6?
That should be 5.
Yeah, yeah, right. Okay, right. So that's B. You better fix that. Your original answer is correct. I'm not sure why you change it though. Worries me a bit. That's worry me a bit. Yeah, I'm not sure why you change it. So for part C, why do they tell you the temperature, right?
Part C to tell you
Yeah.
the resistance also.
So same thing, right? So how does the resistance help you with the potential difference? Any idea? Think about it for a while. Huh? Noah, can you hear me louder?
Yeah.
All right. So your video, please. Yeah, Noah. Any updates for me?
Okay. Sorry?
Any updates?
No.
All right. Any homeworks to ask today?
Yeah.
All right. Then I'll be waiting for your video. Sorry, Aryan, you have a question just now, right?
Yeah, the first 2 questions, they are not like the topic isn't tested.
Cell. You mean cell is not tested?
No, I mean the reactive electrodes.
Wait. So I'm referring to midyear talk, page 9. Yeah. So question number 4 is cell, right? So
Yeah.
you're saying that is not tested?
Yeah.
All right. And propene, question 5, propene also not tested. Are you sure?
Yeah.
Because propene is part of alkene, organic chemistry.
Yeah, organic chem isn't tested.
Oh my goodness, your organic chem. So most of the questions here will not be tested for you, lah. Right. So are you doing question 6 then?
Yeah.
All right, sure thing. All right. Okay. Continue skipping those questions. Right. So back to you, Michael. Yeah. So Michael, does knowing the resistance 1 ohm help you in any way for the potential difference? You have no idea, please.
Yeah. Because PD potential difference is a lot of work done over the day.
If you're referring to the formula, then you don't need my help. Because usually if the formula is correct, then it's correct. No, you might not know why though. So are you sure you understand potential difference concept? Yeah. If not, I can explain.
Yeah, sure.
Right. So this 6 volt will totally be divided, potential difference, right? Divided between this guy and this guy, and only these 2 guys. Right? Many teachers explain it differently. I'll just go straight to the answer first and see whether you understand. If this is 4 ohm, he will use up more voltage, for example, rather than the 1 ohm, right? So this guy will use up 4/5 times 6, which is in this case 24/5 ohm. This guy will use 1/5 times 6, which is, well, whatever that is, 6/5 volt. Now, please notice that this plus that is total 6 volt. Yeah, total is 6 volt because I'm just dividing the 6 volt between this guy and that guy. That's what I'm doing. This is how it works. I'm doing a shortcut though, but the shortcut is acceptable. You know where the 4 comes from? This 4. You know where the 5 comes from? Well, the series 5, then this is 1/5. So if you understand this method, this is called the potential difference method, one of the best method out there for understanding series, yeah, then you're done. I'm not sure about this form.
Difference is just 18/5.
Across the alarm system, where is the alarm system? Sorry. Where is the alarm system according to the circuit?
It's here.
Where? Yeah, which is the 4 ohm. So your answer is not 18 over 5. Your answer is 24 over 5. He's not talking about the difference between this and that. Please don't read the question like that. Please understand the question. You're right to say that, oh, this is the alarm system. Oh, then 24 over 5. Oh, something like that. Okay.
Okay.
All right.
Yeah.
So yes, Aryan, you're asking?
For question 6, right?
Yes, for question 6. Yes, for question 6.
The Q and R electrodes,
Yes.
they aren't like in the circuit, like they aren't like useful, right?
They are. So is this the first time you see electrolysis like this electrolysis? Am I correct?
Yeah.
Is this the first time you see 2 combined to 1?
Yeah.
Right. So interestingly, Aryan, this happens quite frequently in exam, but they don't always practice it enough in class or in practice. So we're going to practice that. They are not useless. They are very useful, and I want you to slowly understand why first. So this is the new thing for you. So the circuit must always be complete. For example, the electrolyte kind of connects things also. Make sense?
Yeah.
So the circuit is complete from a physics point of view. That means now this is positive, right? Connected to positive. So the negative will go there. Remember, that's the first thing I teach you, right? Electron flow is like that. So the electron flow is like that, and the electron is like first thing I teach you, electron flow. Correct? Still the same thing.
Yeah.
The second thing I teach you is find out the negative go where, find out the positive go where. So if the negative go here, then the positive will go here. Correct?
Yeah. I don't think you've shared the gem bar with me.
It's in the mid-year talk.
Oh, yeah.
Yeah. So go there, please, quickly, and page 10. Now, it's good for you to respond quickly rather than waiting. Good. So are you there in page 10?
Oh, yeah.
Page 10, please. You're there. Okay. So one more time, I'm going to repeat everything. It's good that you respond to me because you send something. So electron flow. Make sense or not?
Yeah.
Because it depends on the battery, right? So electron flow. Then the second thing I teach you is the negative ion will go here, if that makes sense.
Yeah.
So automatically, this is the positive ion, even though it doesn't look like it's connected to the battery, but it will still be like that. Meaning to say, this is still the cathode because positive go there, right? Cathode, cation, and this is anode because anion goes there. Still the cathode and cell. So this Q is still useful, even though it looks like it's not connected to the battery directly. Still like that, because look at the electron flow. The electron flow is going in, correct or not?
Yeah.
So that's just the same as if it is connected to the battery directly, electron is going in. So same thing, if that makes sense to you.
Yeah.
So negative goes here, same thing, and then positive goes here. So therefore, this is still cathode. Again, electron goes in, and this is anode. What they call it? Electron goes out, and you can think normally from this point of view from now on. Make sense?
Yeah.
Okay, please give it a try. Yeah. Remember this new thing. Noah, any questions so far?
Yeah.
All right, Michael, don't wait for me. Do something else. Please don't wait. Okay, zoom in, please. Okay, that's nice. Align, please. Okay, thank you. Right, I've taken a picture and I put it in your Jamboard. Noah, we're still using the same Jamboard as last week because it's not full yet. So put it 24 April. Are you at page 11, Noah? Of the Jamboard. All right, so tell me what your question is, Noah.
Already the entire question.
Your first time asking this kind of thing, yeah? Right. So the box of A and B, it is resistor, so they tell you, right? So it's resistor. So it's gonna have a total resistor and total resistor, right? So they make it very confusing for us because the box cannot be seen, right? Now, with the 8 voltmeter, found the voltage A is very much higher than voltage B. Determine which box, right? So, do you understand the concept of voltage divider? Voltage divider is something that happen in series. So obviously, A and B is in series. Even though inside A and inside B is parallel. A and B is still in series. Make sense?
Yeah.
So the 15 volt will be divided basically between A and B. That's just what voltage divider means. So I'm dividing. He's saying that the A is a lot of voltage. So I'm just going to pretend that, for example, that's 14 volt. It's just a pretend, okay? This is 1 volt. Just pretend, okay?
Yeah.
Now, the rule of voltage divider is a shortcut. It's a very good shortcut that I am a lot of voltage because I am a lot of resistance. I am a little voltage because I am a little resistance. Okay. Okay. So this implies that my resistance is big. This implies that my resistance is small. Now, before I explain this, do you already understand up to this point?
Yeah.
All right, so now let's settle the R big and R small. That means let's see what happened. So he's telling me that this is 4 in parallel, 4 in parallel. One of these 8 has 12, and each of the 7 has a value of 12 kV. I see. It's quite obvious, I suppose. So when things are in parallel, let's say this is 12k ohm, 12k ohm, 12k ohm, 12k ohm, right? And then the other guy is, the other guy is 12k, 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 and then 12, correct? Right?
Yeah.
So basically, this, the R effective will be 12k divided by 4, right? 12k ohm divided by 4 equals to 3k ohm. Did you reach 3k ohm? You did not reach 3k ohm. So let me ask you something. This,
yeah.
oh,
I did the other day.
Yeah, I'm very confused. I don't see any 3k ohm here. I'm a bit worried. I should be seeing 3k ohm. This one, I should be seeing, basically, I should be seeing something very close to 12 ohm, basically. Maybe 11 point something, maybe equals to 11 point, I don't know, 999 something. That's my prediction. I'm not seeing these two numbers, so I'm a bit worried. I don't know what's going on here. I'm a bit confused what's going on here. This looks totally wrong. This really looks totally wrong. Yeah. Okay.
Yeah.
So this is the proper number, 3k ohm and almost 12 ohm. So it's quite obvious that B will contain this one because it's the smaller resistance, and A will contain that. Because again, the voltage divider rule, big R, big V, small r, small v. Okay. Okay. I'm doing a lot of shortcut. If you don't understand, you tell me. I was assuming that, oh, you know some basics, but I'm a bit surprised when I see your calculation.
Oh,
okay? It worries me a bit. You understand? Okay, good. Okay, Michael, where are you? Michael, where are you? Let's go back to the question. Right.
Yeah.
All right, explain how the bell, you want D, right? So explain for me your question, your answer, please.
So like, outside my head so far is temperature gets higher, resistance of
the thing gets slower, right?
Yeah,
good, good. Then
the potential difference of it will be lower, and then a higher
across who? Lower across who?
Across resistor X.
Good, and higher, therefore, across the alarm system, correct?
Yeah.
Therefore, and then?
Therefore, alarm will receive enough
voltage
to be activated.
Your answer makes sense to me. Why do you stop? Okay. Hey, look, it's good to me. It feels like you understand the circuit. It feels that you understand potential difference, and your English is also great.
What exactly is potential difference?
Right. Now, let me explain, but it'll take some time. Go to page 11, yeah? Before you do...
Because potential difference, I learned it in chemistry, electrolysis between like the reactivities of what two elements. As the-
Unfortunately, they don't explain it in terms of circuit. So
Yeah.
it's like they are different concept, even though they are connected. So unfortunately, chemistry doesn't help you in context of physics. Because in physics, we are worried about the circuit, right? Okay. Now, before I explain, I just want to check with Aryan first. You do something else. Like, Aryan, are you okay?
Yeah.
What's any questions so far?
Yeah, the question 39, the MCQ question.
39, you're already at 39. So
39.
you're already at because you skipped a few, yeah. Okay, I understand. Right. So water is a product. Okay, then this
29,
one
29.
39, right?
29.
29. I'm sorry.
It's on page 13.
Page 13. Oh, you're skipping a lot, right? Obviously, right? Yeah, because you don't. Right. So at page 29, you have something. So what's your question?
It's just I don't know how to go about doing this. I'm not sure this is tested.
Well, hold your. Oh well. Did you discuss cell? After electrolysis is cell, but I don't think so, right? I think so.
Yeah, I didn't.
Fine, you can skip this one first. 30 you cannot skip. Do you know why?
Yeah.
Okay, then do 30.
It's a normal electrolysis question.
Correct. It's upside down, but same thing. Same thing, cell electrolysis. So try to figure it out. Right, Mike, I'm back to you. Okay, I want to explain potential difference here. Right, so at chem 11, right? Not complicated. It's not complicated. Actually, I want you to understand this. Right? So let's say this is 6 volt, okay? Let's say this is 1 ohm, 1 ohm, and 1 ohm. Not complicated. This is automatically a potential divider. The 6 volt will be divided between these two. All right. Okay.
The
So
potential difference of the first one is
2 volt, 2 volt, and 2 volt. Simple enough, huh? Simple enough, right? Everything should be the same because everything has. Now, let me explain potential difference. Now, there are 3 types of potential. To understand it fully, 3 types of potential. Once you understand the 3 types, it's extremely easy to understand. 3 types of potential. First is potential rise. Second is potential drop. And then third is potential at a point. Potential rise only done by a battery. The job of a battery is to raise the potential. That easy. Potential drop in O level happens in resistance. Also not complicated. A resistance will drop a potential. Remember the water cycle?
the water cycle.
Yeah, I use water cycle to explain. Here's the sea, here's the sun. The sea is evaporated by the sun. What's the sun's job in the cycle? Keeping it very simple, the sun's job is to raise the water from the sea to the sky in the form of clouds. Did that make sense? Then from the cloud, it will rain, and then it can flow as a river and whatever. Okay. The water cycle depends on rise and then travel if you want to, then drop, then rise again and then drop. Make sense? The battery is the sun. The battery raises the potential. The resistance drops the potential. Okay. Now, potential at a point. Extremely simple to understand. C is considered 0 meter, correct?
Yeah.
The cloud, let's say, is 10,000 meter. Let's just say that, okay? 10K. And then you rain to a top of mountain, let's say 3,000 meter. 3,000 meter. So, the sun raises 10,000 meter, correct? Equivalent to 10,000 potential from what? From 0 meter to 10,000 meter. Looks simple. Now, the rain drops how many? The rain drops how many?
The rain drops.
How many meter? Simple math. Come on.
7,000.
7,000 meter, but from where? From 10,000 to 3,000. If that makes sense.
Okay.
This is therefore voltage at a point, that is the height lah. Voltage at a point, the height lah. Voltage at a point. This is voltage drop. This is voltage raise. Not very complicated. What's the voltage drop or the height drop of the river?
The river.
Drops.
Where's the river?
This is the river. So just pretend that there's a very weird river and waterfall and everything lah.
Oh,
The river drops.
3,000.
Yeah, meter. From 3,000 meter to 0 meter. Okay, makes sense, right? Now, what is the voltage at this point? Is 0 volt. What's the voltage at this point? 6 volt. The battery raises from 0 to 6. Okay.
Okay.
This is also 6 volt because nothing happens in between. Nothing happens means there's no resistance, there's no extra battery. Just keep 6 volt as 6 volt. Okay.
Yeah.
What is the voltage at this point? 4 volt. What's the voltage at this point? 2 volt. What is the voltage at this point? 0 volt. Okay.
Yeah.
So now you know 3 potential. Nothing fancy. One raises, one drops, and then in the middle you have voltage at a point. Okay.
Yeah.
Go back to your question. What is potential difference? It's very simple. Potential difference measure the difference between 2 points. What is the potential difference of this resistor? Actually, his question means what's the potential difference between the left of the resistor and the right of the resistor? That's what he means.
Oh,
It's 2 volt loop. Why? From 6 to 4.
okay.
This one is also 2 volt. Why? From 4 to 2. The difference is 2. This one from 2 to 0. The difference is 2. If you measure this, the difference is 6.
Okay.
Now, if you measure this as the voltage difference, what's the voltage difference between this and that?
0.
Yeah. What's the voltage difference between this?
4.
Yeah. What's the voltage difference between this?
Also 4.
Yeah. This?
2.
Yeah. Do you understand potential difference?
Yeah.
That's it. We'll practice more in the question, but that's all there is. That's all there is. Okay.
Okay. Sorry, back to the part D thing, right? So
Yeah.
if the potential difference is higher, that means
Yeah.
the alarm will receive a lower or very low voltage.
That doesn't make sense. No.
Like the
No, no, no.
potential difference of X.
Oh, lower. If the X is lower, then you shift more to the alarm system. Shift more, if that makes sense.
Okay.
Right, because then you drop little there, so you drop more here. Everything has to be total 5, that kind of thing. Total 6, sorry, total 6, that kind of thing.
Okay.
Right. If that makes sense, that's a very important concept. You shift the voltage, always happening. Okay.
Yeah.
Right now, Aryan, any questions so far? Noah, you do other things first. You do other things first. Aryan, any question?
No, I'm done with like questions.
Because basically these questions are not suitable for you, isn't it?
Yeah.
Right. Now, I have an option for you. You want to practice more AMAT or you want to practice more chemistry for prelim? For midyear, sorry.
I think I would like to practice more chemistry.
Okay, then I will send you a prelim paper. What does that mean? You have to choose your questions.
Yeah.
That means you have to know your topics. You know your topics for midyear?
Yeah.
Okay, then I'm sending you. In fact, I've already shared with you. Have I shared with you the chemistry?
I think you have.
Right, so go there, choose the first guy, and then practice the topics, and then ask me questions. Right?
This is the O-level chem, right?
The O-level chem. Choose the 2019 one, the most current one, and then choose the first paper. Should be good enough. Okay. I want you to practice not the MCQ first. I want you to practice the short answer first. Okay.
Yeah.
Right. So I will follow you from there. Noah, what's your question?
What do you ask me?
Yes, I'm asking you. What is your question?
How do I put it into words?
Which one? Sorry. Your connection is a bit. Now it's better. Right. Which one is it? Part B? Is it part B?
Yeah.
Right. Now, let me tell you the good news about physics lah, at least lah. Even though he say explain, if you do your working, it's totally acceptable because this one can do working one. Do you understand? A working.
Distracted for something.
Like the pencil working, like the pen. Oh wait, the pencil working. I'm not sure whether I understand, but the pencil working at least arrive at 11.96 and 3 kR. So you put that pencil working in the B, and then you continue. Then you must continue further lah to connect the 3K ohm with the higher voltage lah. You have to connect that lah. Once you do that, you don't have to put it in English per se. This answer is totally acceptable. In fact, the pencil already give you maybe, let's say at this point 1 mark lah, but it's a very good start. Okay, understand? Okay. So especially in physics, you don't have to always explain in English. You can supplement only. Can also give it a try. Okay. Yes, Aryan.
There's no paper 2 for the Anderson secondary for the.
Wait, let me check. How come? Okay, I thought there is. Wait, let me check. I thought there is. Yeah, Anderson. Yeah. That's weird. So this guy is not Anderson. No. Oh, that's so weird. What? Oh wow. What? Never mind. Skip Anderson and assumption is fine. Because the assumption one, the short answer, yeah, no problem. Wait, what? That's so weird. Anderson has an answer key, but don't have the. What? Okay, let's not bother with it. Let's just go to assumption. Yeah? Let's go to assumption. Yeah, let's just go to assumption. If you're unsure about a topic, Aryan, please ask me and then I'll explain. Oh, this topic is this, then you know, yeah, for me here. Yeah. Okay. Michael, any questions so far? Michael? You are muted, Michael.
Yeah.
Right. Any question? Because we're almost at the end of our 45 minutes.
I don't think so.
All right. So if we start our mid-year practice right now, it's fine?
Yeah.
Good. Right. Your choice, A-math or chemistry?
Wait, sorry, what? E-math or chemistry?
Oh, A-math or chemistry.
A-math or chemistry? I'll do chem.
Right. I send you the chemistry practice in your WhatsApp. It is also in the mid-year talk Jamboard, so a different Jamboard. Yeah. I believe the topics you are tested. So let's use it as a practice, okay? Right. So you refer to your WhatsApp, but you must also refer to the Jamboard because I will discuss you through the Jamboard. So I guess might as well refer to the Jamboard. Yeah. The Jamboard is mid-year talk. Right. I'm going to follow your working, treat this as a homework, and any question, please ask. These questions should be slightly more advanced or more complicated than your practice until now. Should be. Right. No one, any questions so far?
No.
So yeah, I'm seeing that. Okay, so you have the 2R and then you have to connect. Yeah, you have to repeat the voltage divider lah, basically the voltage divider rule. That's the sentence part lah. That's the English part. Okay, Aryan, just tell me which question you're doing right now.
I'm doing the first one.
The first. I suppose this can happen in your mid-year. I suppose. I'm not sure, but I suppose. Okay. Don't take too long. Noah, so for the basic phrasing, I think it is important to mention due to because of voltage divider, something like that. So at the start, and voltage divider is simply a series, a resistor in series. So that's a voltage divider. And then what you're saying is how voltage divider works. So it's good to mention that from the start. That's not just an acceptable phrase, but that is a good phrase to use. Okay. Makes communication easier with your teacher. Okay, so the hand seems fine. So looks like you're more comfortable after writing down the working, right? No,
Yeah.
you're muted. Yeah. So feel free to use this anytime in physics. This is like totally legit. Okay, understand it? Totally legit.
Okay.
Okay, Michael, you okay so far? You're doing that. Let's see. So following you, Michael, right? You should be at page 9. Yeah, you should be at page 9. Michael, is this electrolysis or is this cell? How do you know?
What's cell?
Oh dear. So for the electrolysis chapter, do you know that or rather, do you learn electrolysis and then the cousin, the counter cell, the cousin? So you did learn the cousin, just checking.
What's the cousin?
Cell, battery.
Cell, yeah, I think.
Oh yeah, that was. So this is the cousin, the battery, or this is electrolysis?
Yeah, cousin.
How do you know?
There's no battery.
Fair enough. Fair enough. I like that thinking. I like that thinking better than you say. Oh, the question say.
This is potential difference.
True. This will be potential difference. In fact, the last part is potential difference. Let me get this very clear. So chemistry only learn why the potential difference in battery is 1.5 volt, for example. So he's only talking about potential rise. No,
I never really understood what no, I understand the potential difference is like zinc is more willing to give up the electrons, right? So the
something like that.
flow is from
So
zinc to copper.
and then copper will.
But then I don't understand the voltage. I mean, the greater the difference in reactivity, the greater the voltage. But that's
yes.
it. I don't
Correct.
like. Can you calculate a number or like what?
Right. Let me explain. You cannot,
Okay.
but because nobody can.
Okay.
Because in A level, if you take chemistry, if that's your thing, they will explain to you where this number come from. Do you know where it comes from?
No idea.
No formula. They didn't explain O level. So your objections are very fair. They never explain that this is just from experiment. They basically experiment and plug in a voltmeter and then just measure the voltmeter. Just read the voltmeter. That's all they do.
Okay.
Why is 1.10, 1.10? I don't know, but that's what the voltmeter say every time. So it's experimental instead of like a formula, so to speak. If you can accept that, then for us and for everybody else, basically, that's all the knowledge we need. Right? Good enough knowledge is what I'm trying to say. Your knowledge is good enough, nothing expected more. Yeah. Okay, good. Aryan, you okay so far?
Yeah.
All right, cool. Noah, any questions so far?
Oh yeah.
Show me the question. Okay, definitely a question worthy for the pure sciences lah. So, okay, right. So, Noah. All right. So tell me what your question is. Jamboard, page 12. Huh?
How do I find it? Oh, even the resistance.
How do you find the sorry. What do you want the resistance? Sorry.
How do I
You
find
want
voltage?
right. So a few details. I was telling you that this is worthy of a pure science student. So be prepared to learn more. This guy is not participating in the circuit. Does that make sense?
Okay.
Why?
Not,
Sorry, I cannot hear you. You was cut off.
because he's not in this thing.
All right. So the loop is like that, right? That's the closed circuit loop. So he's not in the loop. He is part of the measurement, but he does not contribute at all. So he can be ignored. If you know that, that's already good enough. So ignore. Can you? So far, so good. So now you have 12 volt, and then this, you must know, is this series or parallel or something else?
Series.
So 3 series is not very difficult. That means the voltage divider will be divided into these 3. Now, they are conveniently the same, isn't it?
Yeah.
They are ugly numbers, and who cares? Because this will be 4 volt, this will be 4 volt, this will be 4 volt. Confirm, without much measurement, without much calculation. Do you know why?
It's same resistance.
All right, so the ugly number doesn't matter. It's very convenient. So what is voltage AB? Because this doesn't matter, you're just measuring the voltage difference of this guy. You already have the answer. It's 4 volt. Now, can you accept or understand that?
Wait, how come again? After 4 volts, then what?
Again, so measurement of VAB, you will be connecting this to a voltmeter. In lab, that's what you will do, correct? So even though this looks like a complete circuit, remember that a voltmeter is infinite resistance. Remember that? Infinite resistance. So there will be no current going here. So I equals to 0. Meaning to say, again, this can be ignored. Same conclusion one. Right? So if this is ignored, then the voltmeter is again just measuring the voltage across this guy. It's just what he's doing across this guy. So 4 volt, if that makes sense. Like this guy is just messing with you, basically. He's messing with you. If you are not messed up by him, well, not so complicated. Right? I guess that's a learning point. Oh, that guy can be ignored because blah, blah, blah. Okay?
Okay, then.
Right.
Yeah.
Aryan, you okay so far?
Yeah.
All right. Again, I see that you're doing question 2. Am I correct?
Yeah.
I don't think question 2 is part of a mid-year, you know. It's part of Sec 3 . I don't think question 2 is part of mid-year.
It is.
You sure? What is the topic for mid-year? Again, help me remember again. I'm happy that you can do it, but I'm happy for prelim . Like, are you sure mid-year is this? Like, tell me, read for me again the topics for mid-year.
It's chemical bonding and structure of matter.
Oh my goodness, it is in, isn't it?
There's more concept.
Okay, confirm is in. Wow, I'm a bit surprised. Yeah, a bit surprised. No, it's okay, Good, yeah, definitely in. So those are Sec 3 stuff. Your mid-year includes Sec 3 stuff, really.
Yeah.
Cool stuff. Okay, sure thing. Good then, sure thing.
Wait, what's the energy from chemicals?
Energy, if they say energy in chemistry, most likely is the enthalpy thingy.
Oh yeah.
Exothermic, endothermic, the graph thingy.
Oh yeah, yeah.
Yeah. So it will be here. Is usually in for example, you can see it in page question 8. Look at that, question 8.
Yeah.
All right. So remember to practice that. Okay. Any confusion or topics, you must tell me. Yeah? Okay, Mike, I lost you. I think I cannot see the video. Oh yeah. Michael, any questions so far?
Don't think so.
Right. Okay.
What's the formula of bromine liquid? Is PR2?
Bromine liquid. Yes, bromine liquid is still Br2. Yes, even though sometimes we say it's gas, but you know it's between gas and liquid. Actually, do you know that bromine is between gas and liquid? So you have both at the same time in room temperature. You have the bromine gas, which is toxic, and you have the bromine liquid, which is also toxic. Same thing.
Okay, for a question 5
Yes.
and page 9.
Yes, 5A.
Do I need to like take note of anything when calculating the moles with the double bond?
You need to know the reaction.
Huh?
You need to know the reaction. So my concern is if you don't start with the reaction, I'm very concerned. Very, very concerned. You have my reaction map, right? Take out my reaction map, remember? The one on paper, right? So if you don't think to the reaction map, I'm worried because that means you're not writing any reaction, means what you're doing is probably not correct. I mean, at least you go and find the mole. So I'm happy for that, but you cannot continue without the reaction. Again, you cannot. So take out the reaction map and then tell me this question's reaction is which one. That's what I want you to think about. Okay, Aryan, everything okay so far?
Yeah.
All right. Okay. Do practice the harder topics, yeah, not the easier one. Right? So if you find this current topic to be easier, actually skip that, please, so that in tuition you can do harder ones. All right. I know if you answer correctly, it feels great, but if an easy topic, you don't need tuition. Huh? Do the harder ones, okay?
Yeah.
Challenge yourself, tuition more than normal. Right? Be braver. Be braver. Noah, any problems so far? You're muted, Noah. Noah, any problems? You're muted, Noah.
No problem.
All right, understand. All right, Michael. Now, which reaction is this question?
The alkene.
Alkene to which one? Very good. You are supposed to be able to write down the reaction in terms of chemical formula. Also, this guy plus PR2 becomes what? You need to be able to write that down as a practice. So give it a try. Give it a try. Let me follow. So this is like C3H6, right?
Yeah.
CH6 and then plus 2. And then what does it become? You must look at your reaction map and be confident. It becomes C3H. What's that? H what? Sorry, I cannot read it.
H6.
That doesn't make sense. What you're writing doesn't make sense. No, it does make sense. I'm so sorry. It does make sense. What am I talking about? It does. Do you need to balance it?
No.
All right. So based on this reaction, will you be able to proceed better? No idea.
No idea.
The mole that you calculated looks great. Whose mole is that?
C3H6.
Is that mole useful for something?
Yeah.
Hey, the BR2 is wrongly written. Okay, that's not a good way to write BR2. Okay, nice. So what is the mole used for?
Yeah, you calculate you times the molar mass, the atomic mass of the BR2.
Because their mole is the same, correct?
Yeah.
So is the reaction useful or not?
Yeah.
Is the reaction a must or it's just a bonus?
No, must. That's a bonus.
I feel it's a must lah, to confirm.
Okay,
I feel
so
like.
this times BR2, right? So it's times 160.
Actually, I forget the MR or BR2 you have to work on.
BR is 80.
Okay, that's nice. Right. So it just times that and then you have it. You'll notice this kind of question happening from time to time. Organic chem with mole. So be prepared for that.
Okay.
Aryan, everything okay so far?
Yeah,
Which question are you doing right now?
I'm doing. I was doing to be part two. I'm just looking for another question.
Yes, something more challenging, please. Right. For example, question 7, if it is in lah, or question 8. Question 8, I think at least must practice lah.
Sorry, go. Yeah, go
Yes.
to the restroom.
Yes. Quickly go. All right. No one, any questions so far?
Yeah, but I have to go take it.
Yeah, okay, sure. Everybody half an hour left. So let's use it well.
Wait,
Yes.
what's the topic for question 7?
What is the graph? So sorry, you're asking what's the graph, is it?
The topic.
Oh, energy, enthalpy change.
Question 7.
I'm sorry. I thought question 8. Question 7 is acid, base, and salt. Specifically, this is preparation of salt. Is it in mid-year or not?
Yeah, it is.
My goodness, all the old topics from Sec 3 is in.
Yeah, I'm pretty sure all the topics are in.
Oh my goodness. We are not even at prelim. Why torture you? Like, never mind. It is. Do you know how to do question 7?
Yeah.
All right, give it a try. If it's old, maybe we are a bit rusty, right? Yes, Aryan.
Can you go to the washroom?
Yes, quickly, Aryan. I'll see you soon.
Question.
Yes. Yes, Noah. Show me. What's the question? Okay. Let me copy first. Hence. Okay. Then you must show me both. Sorry. You must show me both. Okay, nice. Let me copy first. So this is where you should suspect, right? The integration is impossible without the hint. The hint is given in part 1. Am I correct? So what is your concern?
Does this number 1 and 0 on top of the integration make a difference in the answer? Or can I do it like without the 1 and 0?
I'm very concerned with how you integrate. Sorry, I'm very concerned with how you integrate. So actually, I'm very concerned with how you integrate. Now, remember your test. Remember the test. I like how to confirm differentiation. Remember that the neighboring method, the neighbor points. Would you please apply that to your answer in part 1, and then I'll explain what's happening. Okay, let's take time to test this answer from part. Confirm your part 1. Confirm your part 1, and then tell me what's the result. Okay. Right. Okay, Michael and Aryan, have you come back?
Hello?
Yes. Aryan, you are back.
Oh, yeah.
Yes. Any questions?
No.
All right. Michael, oh, sorry, Michael, you're back. So any questions? Right. So Noah, sorry, yeah, I wasn't looking at that. So Noah, your confirmation say that it is correct. I'm very surprised. Let me see for a while. Let me just check one more time. Sorry, yeah. Surprised there. Let me just check that there is nothing wrong. Well, actually, you cannot say that there is anything wrong, isn't it? Well, sorry to have doubted you, right? I would have done it differently, but well, turns out you are correct. Eh? So now that I think of it, I guess that's fine. All right. So now, what's your problem between part 1 and part 2? Is it how to use part 1? Noah?
Oh, I'll try reattempting the question
Sorry, you're saying? Sorry?
to see if I.
No, I cannot hear you. Sorry.
I want to try reattempting the question.
Okay. All right.
I
Sure.
want to try redoing the question.
All right. Right. Okay. Michael, any
Okay,
right.
I believe my part A for question 6 is pretty much all right.
Let me check, because I need to copy, so it's more easier, right? Okay. We're at question 6. Yeah, that's nice. I'm gonna copy that. All right. So is this new to you? Just checking, like 2 electrolysis combined, right? Like in series, lah.
Or when it comes to school,
I suppose school. Have you seen this before?
school, don't remember.
But you have no problem doing this.
No.
Sure. So let me check. P, you're saying that the OH minus will win. Like the electron. Yeah, I like it. I like it very much. And you're saying that that will be, yeah, I like it pretty much. And the reaction is fine. Now for S, yes, right? So S, you'll be that. And I totally agree with you. Great. So how about part E?
Yeah, so I don't know if my explanation needs like more to be in depth or something. I don't know.
Okay. So I will start with, to me, actually, I suppose I don't mind, but I will shorten. I will greatly shorten my English sentence by basically writing down the R reaction first.
That's my concept, correct?
Okay. I just wish that you've written the R reaction. So basically, you mentioned the R reaction in English, lah, right? Yeah. So the R reaction is again the 4OH minus again, right? Blah 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 blah. Again, I hope that you will do this in reaction form, and that will be great, right? So concept-wise, however, I like it a lot. So basically, your pH will increase.
I mean, they never ask for whether it increase or not, but like.
Oh, you should mention increase there, because basically OH minus is being reduced lah. You have more. Basically, that's where the pH increase from, not from the increase of H plus, but from the decrease of OH minus.
Yeah.
So the H perfect. I mean, looking at your working, I wouldn't suspect that your chemistry class is not so good lah.
I mean, I am not the chemistry class.
No, I mean your school chemistry class. Right?
No, I didn't learn this in chem. Or
where did you learn this then?
My friend.
Your friend's fine. Okay, cool. Sounds good to me. But again, I will just suggest the reaction format. Everything is fine. Okay, cool.
So, okay, reaction format is what I
you write down. You basically write down like you basically write down that, but you say that's in R at R this. Then you continue for the second half of the sentence. It's fine.
Okay.
Yeah. They like it lah. They like it when you write reaction. Just want to say that, but they don't mind if you write English. They like it better if you write reaction. Yes, Aryan, any questions so far?
No.
All right. So Noah, just confirm me, are you using the integrate both side kind of method?
Yeah,
From part
still
one.
figuring out.
Yeah, you should be trying that definitely. That's just the go-to method lah. Every time things are a bit confusing, you should try that first. Let's see how it works. Let's see how it works. Oh my goodness, 12 more minutes. So let's make full use of it. Again, Aryan, do challenging questions. Do challenging questions.
God.
Yes, Michael.
Can I confirm whether my question 30 and 31 are correct?
Yep, let me check. Question, sorry, yeah, question, wait, here. Your question 30 is A, I believe.
Yeah.
Right, let's check. You understand that this is meant to be sacrificial protection, but probably the sacrificial protection went wrong, because you do not want the screw to be heavily corroded.
Yeah.
Right. But do you mind if actually both things shouldn't be corroded lah. Both things shouldn't be lah. But that's just how nature works lah, right? So your answer is A. So I'm gonna put it here. So Cu is less reactive than Fe. So Fe will corrode first, keeping it simple, yeah, I suppose, yeah. Right. So how come it doesn't happen with B? That's my question for you lah. Because zinc also more reactive than Cu.
Yeah.
Yeah, you should consider that. You should consider that. Right. Zinc is even more reactive than the Fe in the steel. Right. So consider that for a while. Think about it for a while. I mean, this is good. This is a good question to consider. Now, how about 31? What's your question? What's your answer? 31 is A. Right?
Also A.
Right. So it's a cell, right? And your consideration should be that ZnCu is the furthest apart, I guess. compared to MgPB, right? But what's the okay? MgPB and ZnCu is quite about the same distance, right? So why didn't you choose D, for example?
Because it is glucose.
Yeah, so it's not a good thing. Okay, good. No, good enough. Good enough.
I assume the reason for it is because it's what complex. Yeah, complex molecule.
Oh, glucose, is it?
Yeah.
No. Electrolyte is basically conductor in liquid form. The job is to conduct, and of course it can also react, but the first job is to conduct. Glucose cannot conduct. But why? Because glucose doesn't form ions, keeping it simple. It doesn't form positive or negative, and that's why it doesn't conduct well. Yeah, so distilled water about the same thing. Right? Right, good job. Please continue. Noah, are you okay so far?
Seems like it.
All right. Okay. Let me see when you're done. Aryan, are you okay so far?
I kind of forgot the process of crystallization, like the steps.
Which question? Sorry, which question are we talking about?
7B part 2.
Still 7, is it? Oh, 7B part 2. Okay. So the crystallization part only, is it?
Yeah.
So keeping it simple, right? Keeping it simple. If that's the only concern, you just have to memorize. I'll just refresh your memory. So you already have the aqueous form, right?
Yeah.
Right. Then you will reduce by heating. That means you're going to evaporate the solvent, right? The solvent, which is water, you're going to reduce by heating the solvent, and it will start to crystallize after a while.
Oh.
And then after the solvent is almost gone, it cannot be completely gone. So you must wash the crystal with the ionized water, just spray, right? Then that's you're washing the final solvent out. Okay. And then you dab with actually I forgot what you dab it, but you just have to dry it with some sort of acceptable cloth.
Is it filter paper?
Yeah, with that paper. Sorry, long time. So that's the 3 steps. Reduce the solvent by heating, wash with the ionized water, and then dab it dry. Is that what you're asking?
Yeah.
All right. Okay. Please don't write it down. I mean, it's just memorization. Please go to question 8. Let's try question 8 first before we end. We only have 5 minutes left. Okay. Right. You can always look at the answer key, by the way, so you don't have to worry too much with the correct sentencing. Yes, Michael.
I still have no idea about the FE thing.
Right. So I'm going to keep this in mind, like what is this, right? And then see what happened next week, right? So don't worry, I've already hinted. Ding, 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 what's going on here, right? Let's go to, maybe you can do 2 more questions, Michael, at least, right? At least. 3. questions so far, guys? Any question, guys?
No.
All right. So first time I assign you homework. Try to do this whole paper too, the relevant topics only throughout this week. Right? This is not the highest priority. You have your school homework as a priority, but this is definitely a practice for mid-year anyway. Right? So if your teacher is not giving you practices, this is the practice. We're starting early. If your teacher is giving you mid-year practices, you can feel free to ignore this, obviously. Okay, so this is the homework. You do have the answer key, but we should talk about again why you don't know certain questions. Right? Now, with that in mind, I'm quite happy with your progress today, and I will see you on Tuesday. All right? Right. Same thing with you, Michael. So just to confirm, Michael, currently no question.
No.
Continue doing the questions, Michael. So again, this is the first time I assign you homework after quite some time, right? Try to do the chemistry throughout this week as a preparation for your mid-year. You, however, do not have an answer key. So slightly different, yeah? Okay. All right. I'll see you on Tuesday then. Right?
Bye.
So, bye-bye. Noah, are you okay? Oh, you're showing me that already. I like it. I like it. Because you divide by -2. Yeah, like it. Okay. And the integration of that. So oh yeah, you can integrate. Huh. Oh, let me confirm the. Sorry, let me confirm something, Noah, because I'm a bit confused with your working. Let's look at the Jamboard. So still page 13, yeah? Still loading, yeah?
Yeah.
Again, I hope you're not waiting for me, but you should be doing something. Now, is this X or is this just times? Noah, looking at the Jamboard, X or times? Oh, well, then it's times, then I kind of agree. kind of agree. The presentation. Okay, so I would prefer presentation wise. So nothing wrong then. Presentation wise, I prefer that you just do that without the X, because it may just be confusing for your examiner. Just avoiding that, and maybe also ourselves if we are under pressure. We may forget that we meant it times not X, maybe a bit confusing. So I think this is better. Okay.
Okay.
Right. Other than that, great. Okay. If there's no other question, I will see you on Tuesday then.
Okay.
Right.